We are at the dawn of a new era. Well, thousands of new worlds were discovered, thousands of exoplanets. And, well, tonight, try to look at the sky and all the stars that you will see, even the tiniest ones, even the faintest, they all have planets around them. You imagine that? How many billions and billions of planets that are around us in the sky. And we live, in fact, in a new paradigm. That is, we live below a sky full of stars. But in fact, we live below a sky full of planets. And, well, with so many planets, since I was a kid, I was very intrigued with that. Are we alone in the universe? Could exist life around all the stars? And so that moved me a lot, because this is still today one of the biggest questions in science. And I wanted to be part of this quest, to contribute for this search if there is life elsewhere in the universe. So I became an astrophysicist. I used some of the biggest telescopes in the world. And at the same time, I'm part of several space missions, like Ariel space mission, Envision, Mars Express, and ExoMars, all of them from the European Space Agency. And, well, let's begin our journey into space. And I ask you to go with me, but we start in a temporal trip. We go back in time to a big collision that is already comes in the books. We already know about that a huge body smashed, collided, a big impactor that arrived to Earth, and we call it Theia. It's a name we gave to this. Till now, we all know about that. There is plenty of evidence about that. But what I want to share with you today is in the frontier of science. It doesn't come yet in the books. Even ChatGPT, I believe that is not aware yet. Well, today, of course, that tomorrow all of you will share this on ChatGPT, and tomorrow they will know about that. So the new thing is that the body that collided with Earth was not a regular asteroid. It was an ocean world, a body very rich in water. And is that important? Why is that important? Because life is connected with water, as we will see in a while. Let's see, for instance, how the solar system was formed. The rocky planets, Mars, Venus, and Earth. We used to say that Venus and Mars are totally different from Earth. No. We might say the other way around. Earth is very different from Mars and Venus. I ask your attention for this. Even today, the atmospheres of Venus and Mars are equal in composition. Almost carbon dioxide and a bit of nitrogen. The difference is on Earth. Why the Earth's atmosphere is so different? The answer lies in the water. And why? Because oceans works like a sponge for carbon dioxide. For instance, here in front of the beautiful beaches of Lagos, the ocean is absorbing still tons of carbon dioxide, preventing Earth to be like a furnace, like on Venus, a real incinerator with a greenhouse effect that is uncontrolled. So this body, this water world, this ocean world that reached and this big impactor that arrived to Earth, perhaps is the cause that I'm here talking to you. So please, if you see the moon tonight, somehow for you, I will be for sure, and perhaps some tenderness, because perhaps we owe our lives to this projection, this part of the Earth that was projected to space, and after regaining the spherical form, become our moon. You know, defining life is very difficult. In a conference of the European Astrobiological Conference that was held here in Portugal a couple of months ago, we were hours and hours discussing about what is life. And believe me, I don't have a final definition to give you today. However, all forms of life that we know, they shared same characteristics, three characteristics that are often called the triangle of life. A source of energy, a carbon-based chemistry, and a polar solvent such as water. And this will reach us to the next step. That, for me, is one of the highlights why I wanted to come here and bring perhaps something new to share with you. That is, for this, I need to introduce a new concept, the concept of chirality, the concept of molecular chirality, that is connected with when carbons bond, they bond in two different geometric forms, like mirror images in the two geometric forms that are a mirror from one to the other. And you know that three basic compounds of life, sugars, amino acids, and fat, these three families, two of them are entirely on the right-handed form. And the other one is not 90%, it's 100%. It's totally, entirely on the other geometry. What is the meaning of that? Why is this important? Because all life on Earth, this points out for a common origin of all life that exists on Earth. Us, the elephants, the whales, even the condolipas, very famous here in Lagos, we are all the same family. We are all brothers and sisters, scientifically speaking. And now let's move in our journey to space a little bit further. Let's go to Mars. And on Mars, what I'm studying the water content on Mars, like reservoirs on the water and water in the ice caps in the poles and so, but also a biomarker. What are biomarkers? Biomarkers are molecules that are related to life. Well, when we detect a biomarker, we can't claim that there is life there. However, we can claim that the odds, the probability that life exists or existed in the past dramatically increase. And also, as I said, methane is something that we are studying on Mars, but also the temporal composition on water on Mars, that there is a lot of discussion about this, that in the past there was a huge ocean that covered all the northern hemisphere on Mars. And we are studying the ancient shorelines and the related minerals like clays and hydrated silicates. And well, I didn't, till now, I didn't find any seashell yet. Perhaps I could be much more lucky if I will do the same project here in Meia Praia, nearby Lagos. Also on Venus, there was a biomarker that was claimed to be detected in the atmosphere that is called phosphine. This molecule, why is a biomarker? Because in rocky planets, just life can produce it. For instance, in this very room, all of us, we produced phosphine in our belly. But please, let's keep this study just theoretical, because phosphine is very smelly. So let's move further away. So let's go to the giants, to Jupiter and to Saturn, where there are icy moons that are ocean worlds, like Europa around Jupiter and Enceladus around Saturn, and they eject, they spray their oceans in the out space, and we can study their composition. And their composition has, of course, water, but also complex organic molecules. And was found molecular hydrogen that works as a fuel for life, could be used as a fuel. Also, besides this ocean world, again, these ocean worlds, there are a study that we are doing on Titan, another moon, very bizarre moon on Saturn, that is covered with a very dense atmosphere, denser than ours. And this atmosphere is mainly made of hydrocarbons, and mainly methane and ethane, and there is lakes of ethane, and more important even, that is sometimes look far away in space. It's like looking back to how was our planet in the past, because the atmosphere of Titan today is very similar what was the atmosphere of our beloved planet in the past. Now that we are reaching almost the end of this narrative, let's go back to Earth. Let's look for the counterparts of what we are searching in space, but there is still space for amaze you. And to add, I hope, some lasting memories about this talk. When life appeared on Earth, we know, all of us, we know that it was on the oceans. But at that time, Earth was totally covered by a dense layer of clouds, was dark. So in the ocean, which kind of metabolism will fuel that life that is just appearing? Photosynthesis is a no-go, no chance, no light. And also, for instance, the kind of metabolism that we use, like the glycolysis that is part of the cellular respiration, is also not possible, because now comes what I want to share with you. Life was found very deep in the ocean, in the deep sea near Azores, in the hydrothermal vents, where this volcanic activity produces what you see here, a wonderful burst of life. But this life can't use the metabolism of photosynthesis or the cellular respiration with the glycolysis. And why? Because it's very acidic. So glycolysis doesn't work. And you know why I'm talking about these kind of other metabolisms? Because even us, any of us here, in a place in our body that is dark and is acidic, there is life there. I'm talking about our stomachs. And inside, we have forms of life that could thrive using which kind of metabolism? Based in molecular hydrogen, like here. And you know more? When there was found, we are again in the frontier of science. Last year was found that the chirality of the three families of basic molecules of life, of this almost alien life, It was two parts of them with the right-handed chirality and the other with the other one. So they came from the same genesis of life as us. You look here, our grandfathers and grandmothers, they are there. And more, and more. That is that all of you, all of us, was also find very few time ago that parts of our DNA, some sections that are inactive, but was find that some sections had the codes for producing the machinery to produce this kind of metabolism. So all of us, we are like a repository of the history of the evolution of life on Earth. Each of us, we are like these photos from the babies with all the steps of life. So you are very important. You are an archive about how life prevailed and appeared on Earth. I have a friend, a poet, that used to say, how come from sterile matter was transformed in life? And he used to say that is through of commotion. It was this metamorphosis was from emotion that abiotic, sterile life become alive. Even as a scientist, I love this approach. And finally, we arrive to, and the next steps. How we are finding or looking for if there is life away in these exoplanets, light years from us. How we can do that? Of course, using information, using science, using biomarkers to see if we can find a glimpse of the hypothesis to about if life exists or not, away from us in these deep regions on the space. But if we don't find life elsewhere, don't be sad, because in a distant future, we can plant life in Proxima of Andromeda in other worlds, and then it's just giving time to natural selection, to evolution. And one day, we would be able to spread life in the universe.